So yesterday we looked at this example, right? We had a big system. We had a 4x4 system, and all we had to do was set up our augmented matrix that represents that system, right? Where we're going to put all of the equations in standard form, where we're going in alphabetical order through the variables, even though they this example, they sort of messed it up. We just got to be consistent. So in this case, we're doing the columns go X, Y, Z, W, constant, right? All the way through. We set up our 4x5 matrix, 4 rows for the 4 equations, 5 columns for all the variable coefficients plus the constants. And we set that up as, for example, matrix A in our Desmos matrix calculator. And then we go down and we put that into reduced row echelon form. And when we do that, if we get a single point, this is what it looks like. And you guys had no problem interpreting that, right? The first row is just saying 1 times x equals 2, 1 times y equals 3. Next row, 1 times z equals 0, 1 times w equals 1. And we write it all up as an ordered quadruple, and we're set, okay? Okay, but what about something like this? What if we set up this system? So here we've got a 3x3 system that we're solving with technology. And so we set up our system matrix right here, augmented matrix. Well, actually, that's not it. We set it up, and then we did reduced row echelon form on it. Okay, same as before. We would just set up a 3x4 for matrix A with all those coefficients, and then we do our reduced row echelon form. And what is this telling us? Everyone, click and close for a second. Just take a look up here. I want you guys to see how do we interpret this. This is kind of weird. What do you notice that's a little odd there? Which one of those rows makes no sense? Third one. Third one makes no sense. Look what that's saying. 0x plus 0y plus 0z equals 1. So this is equivalent to saying 0 equals 1. How do we interpret that? It's false. So what is this? What kind of a system is this? Yeah, it's inconsistent, right? There's no solution. There's no intersection here, okay? How about one like this? So we set up here's our matrix that represents the system, right? We put it in reduced row echelon form, and this time, look at that third row. What's it telling us this time? Yeah, 0 equals 0, right? Everybody see that? All the coefficients are 0, and the whole thing is equal to 0. So, now that's true. Okay, that's true. So that's telling us that there are many solutions to this, right? An infinite number of solutions. But when you start to get beyond a 2x2 system, those many solutions can look different, right? What are these other rows telling us about the many solutions? It's not just any possible value of x, y, and z, not just any ordered triple. It has to be ordered triples that are specifically built in a prescribed way. What's that first row telling us? Yeah, x plus 1/7, 1/7 z equals 0, right? Or in other words, if I clear the fractions, I would just get something like 7x equals negative z, or maybe another way of saying that would be z equals negative 7x. Let's say it that way instead. Okay, so it's relating z and x there in a very specific way. How about this second row? Looks like y minus 1/7 z equals 0. So I could rewrite that as z equals 7y. Everybody see that? Okay, so we can't just pick any values. If we pick, depending on which values of x and y we pick, the values of z are, this is all going to have to be consistent, right? There's an infinite number of possibilities, but there's a pattern to what those possibilities could be. Okay, does that make sense? I don't think it ever asks you for the constraints on any of the problems, but I just want you to know kind of what that means. Right now, I'm not going to take the time. I'm going to let you guys finish up that assignment today. How many people still need to finish up the, that's what I figured. So you can have today to kind of wrap up the, what is this, 3.5 practice 3, I'm thinking, or practice 2, is that what it is? 3.5 practice 2? I mean 2.5 practice 2? Yeah. Yeah, okay. The practice 3, you could start on it, but we haven't really, I mean, you can, it's fine. We haven't really talked about those yet. We'll hit that stuff tomorrow. Okay? We good? Okay, have at it. And then we'll take probably, like Friday would be a good day to, because we get Thursday off. Friday would be a good day for us to kind of look at what these, well, I'm going to show you a couple little videos that help you visualize this stuff. That'd be kind of a good day to maybe spend a little time trying to interpret what these 3x3 systems really represent.